Just going to continue on with the examples, because yesterday you did example 1 and 2, and so today we're going to do example 3, 4. Let me see how far I want to get today. 3, 4, and 5. Okay. So we're going to be determining the approximate roots. Let's start with this one. Solve the equation of 5 secant x minus 4 equals 8. Now, I got to pay attention in here because here x is now, we're operating in the degree mode, not radian mode. Okay. So most of our trig stuff that we did, and this is just our exercise for today. The reason why we did this today is because we're going to be using it quite a bit. So when we look at our unit circle, which we've seen many times, the coordinate is really the secant, I'll do x and y, so that's the cos and sine of the angle. Okay, of theta. Now we don't have the secant and the cosecant, but that's okay because the secant and cosecant are just the reciprocal of this, the sine and the cos, respectively. So when we look at this one, this part in here, 5 secant x minus 4 equals to 8. What we're gonna do is we're gonna say, okay, I'm going to try to solve for secant. So 5 secant x minus 4 equals to 8. I'm going to solve for this one first. So I'm going to bring the negative 4 to the other side of the equation. That becomes 5 secant x equals to 12. Okay. And then I gotta solve for that, so divide by 5, so cancel 5. So secant of x equals to 12 over 5. Now, we don't have secant x function on our calculator, so we won't be able to do this. However, we know secant is, we know secant x is equals to 1 over cos of x, right? So if that's the case, secant x is going to be, I'm going to write everything down. It's going to be secant is just the reciprocal of this part. So cos of x is equals to 5 over 12. Okay, the secant is the reciprocal of cos. So if you take the reciprocal of cos, it's going to be the. This one we can recognize. We recognize this piece. Now, how do we solve for x? How do we solve for x? Well, there could be many answers to this, okay? The question that we're going to ask is, well, wait a second, where is cosine positive? Yeah, so we gotta do this. Where is cos positive? And because this is a positive 5/12, right? Where is cos positive? It's gonna be in quadrants 1 and 4. Quadrants 1 and 4. Okay, I'll deal with the restrictions later. Okay, so how do we solve for x? Inverse cos, yes. Cos inverse of 5 over 12. Okay, I know that we're operating in degrees, so I gotta make sure that my calculator says degree mode. Okay, so once it's in degree mode, I can do that. So inverse cos of 5 divided by 12. 5 divided by 12 is going to be 65.4 degrees. 65.4 degrees. Okay. Now, I gotta go back. This is our reference angle, right? This is our reference angle. So, let's see. Our angle is supposed to be in quadrant 1, quadrant 4, right? But look at our restriction in here. Which quadrants are we operating? Okay, so if we go counterclockwise this way, we're gonna hit the quadrant 1 angle, and if we go clockwise this way, we're gonna hit the quadrant 4 angle. So in this case, so x is equals to 65.4 degrees. That's the one to the positive angle, and then the negative angle would be negative 65.4 degrees. Okay, so those are our two solutions. Okay. So this is my strategy sometimes, is I break it up into sections here. So I'm going to figure out the solution from 0 to 180, and then from negative 180 to 0. So sometimes I do that so I am not missing anything. Okay, good. Any questions there? That one's bad, right? So let's take a look at letter B. Solve the equation of 5 minus 3 tan theta equals to 2 tan theta plus 9. Oh, now we're switching it back to this domain from negative pi to 3 pi halves. So how do we do that? We're going to solve for tan.
Just real quick, that when it's like that, does that mean you want to be in radian?
Yeah, so this one here has to be in radian. Yeah, correct. So in this case, what do? We gotta solve for tan. I'm gonna switch over here. So 5 minus 3 tan theta equals to 2 tan theta plus 9. So how did we do this? I can see tan. What can we do? Add together, bring them all in one side. Okay, so it's going to be negative 3 tan theta minus 2 tan theta equals, bring this to the other side, that becomes negative 5 plus 9. Okay. How do we fix this? How do we combine them? Negative 5 tan theta. Is everybody okay with that? So you got negative 3 tan theta, and then you got a negative 2 tan theta. I forgot the theta. So it becomes negative 5 tan theta. Equals to 4. Okay. What's next? Divide by negative 5. So tan theta is equals to 4 divided by negative 5. Then I'm going to stop right there. I got to ask myself, okay, where is tan negative? Where is tan negative? It's going to be in quadrant 2 and 2 and 4. So it's going to be tan is negative in quadrants 2 and 4. Okay. So now here we go. Go back up here. What's theta? We're just going to go 4 divided by 5 to figure out the reference angle. Okay, so 4 divided by 5 is 0.8. So tan inverse of 0.8 is 30.
Degree.
Has to be radian. Thank you. So tan inverse of 4 divided by 5 is going to be 0.67. 0.67 radians. I'm going to put R there. Okay, so that's the reference angle, but that's not the theta. I'm going to put R for reference angle. So what's our theta then? Okay, let's go back and redraw that. Our reference angle is 0.67. 0.67. Okay, next. Now I gotta make sure that I'm within this domain here from negative pi to 3 pi halves. So this is what I do sometimes, okay? I break it up into 2 parts. I go negative pi to 0. I figure out the answer there. Okay, I figure out the answer here. And then I figure out the answer from 0 to 3 pi halves. So that I'm not doing everything all at once. So I'm going to start with from 0 to negative pi. So 0 to negative pi, that's turning this way, negative pi. Am I going to include this part here? No, that's going to be over, right? From 0 to negative pi only. So from here to there, right? So what's the answer there? That's going to be theta is equals to negative 0.67 radians. Okay, so that's, I only have one answer. From 0 to negative pi. What about from 0 to 3 pi halves? Now from 0 to 3 pi halves. Where's 3 pi halves? Up to quadrant number 3 here. So which is a solution? This part here, right? So this is your solution. This is your theta in standard position. That's going to be pi minus 0.67. Pi minus 6.7. So pi minus, pi minus 0.67. It's going to be 2.47. 2.47, and I'll just put R for radians there. Okay. Now let's take. Is everybody okay with this piece?
So this one's positive, right?
Hmm?
We are going to positive.
Yeah, because this angle is the reference angle only. We want the angle in standard position from here to here. So that's actually our booklet number 1. It's going to be pi minus 0.67. Okay. Now let's take a look at this. Example 4. Before I move on to example 4, are there any other questions? Mm-hmm.
Why is there priorities on bracket and otherwise by itself?
This one?
Yeah.
Oh, it's because of this.
Yeah, why?
That's just what's given. So what I did here is I first figured out the negative angles, any solution for the negative angles here, and then I went from 0 to 3 pi halves so that I get everything. Okay, example 4. Determine the general solution of a trigonometric equation. Solve the equation cotangent plus root of 3 equals 0. Okay. Now, cotangent of x, we don't have that in here. Oh, we'll see what kind of solution we're going to get. So, cotangent of x, cotangent x plus root of 3 equals to 0. So that means cotangent of x is equals to negative root of 3. And I'm just going to put over 1. Cotangent of x is equals to negative root of 3 over 1. Now it's easier for us to determine in terms of tangent, right? Cotangent. Cotangent is the reciprocal of the tangent, so we can, what's the tangent of x then? Okay, so it's going to be negative and then 1 over root of 3. Now you look over here. Where is the tangent 1 over root of 3? Tangent is sine over cos. Sine over cos. Do you see it? Okay. Now it's going to be this one, right? But it's going to be negative, so it has to be this part. Okay, where's tangent negative? It's tangent here, negative at 1/2 divided by negative root 3 over 2. That's going to give us the negative 1 over root of 3. Where's the other one? In the 4th quadrant, right? It's going to be over here. So we have two solutions. Let's see. Now it says here 4, 0 to 2 pi. 0 to 2 pi. So that include pretty much a whole circle. So x is equal to, what would that be? Okay. So that becomes 5 pi over 6 and 11 pi over 6. 5 pi over 6 and 11 pi over 6. Okay. So this is the solution from 0 to 2 pi. 0 to 2 pi. Now, what we're going to do is we're going to write the general solution. There's going to be infinitely many, right? There's going to be lots and lots of that. That will give you that solution. So this is the general solution. What would be the general solution? Let's see. It's going to be 5 pi over 6, and then it's going to be 11 pi over 6. Do you notice something in here? From 5 pi over 6 to 11 pi over 6, how much did they turn? Half a circle, which is pi. So every time you turn pi, you're going to get back to those things, right? So if you're over here, you're going to turn this way, right? Every time you turn pi, and every time you turn pi negative way, you're going to get to those points, same points, terminal points again, terminal angles. So the general solution would be 5 pi over 6 plus pi times k number of times that you're gonna rotate, where k is an element of the integer z. Okay, so this is the solution for 0 to 2 pi, but this is the general solution if you want to show all of the solutions. Good. Let's try B. What do you think we should do first? Combine like terms, and I like that when you say combine like terms, because that's basically what we're trying to do, combining like terms. So you go 7 sine theta, and I'm going to bring the 4 to the other side, so minus 4 sine theta equals to negative 1 plus 2. So it's going to be 3 sine theta equals to 1. And then therefore sine theta equals to 1/3. Okay. Is sine theta equal to 1/3 a special angle? No, it's not a special angle. So what we have to do? Well, first of all, where is sine positive? Okay, so it's in quadrants 1 and 2. Okay, so let's figure out our reference angle first. Okay, I'm gonna make sure I'm in the right mode, radian mode still. I have 0.34 radians. That means this is 0.34 and this is 0.34. Okay. Our domain is from 0 to 2 pi first. Okay, so what would that be? So for theta or x between 0 to 2 pi, what's our solution? Would be 0.34, and what's the other one? Pi minus, yeah, yeah. So pi minus 0.34 is 2.80 radians. So we got two solutions for 0 to 2 pi. Now what about the general solution? How can we get the general solution? .34. So how do you always get to this line over here, this terminal angle? So 0.34. Now to get back to this terminal arm, you have to turn how much? 2 pi. So 2 pi k, where k is an element of an integer. Now this is not a pi turn, right? That's not a pi turn. So we have to do this separately. So it's going to be 2.80 plus, how can you get to that part again? It's going to be 2 pi times k, where k is an element of the integer. 2 pi. So if you're over here, to get back to that same terminal arm, you have to go around 2 pi. And if you go 2 pi, you're gonna get to that part. And if you go, this is where you start, and then you're going 2 pi, but negative 2 pi, so turning it this way, then you're gonna get that negative angle there. Is that okay? And then this one here, to get back to this angle here, this terminal arm, you have to go around 2 pi each time. Either positively turning 2 pi or negatively turning 2 pi. Is that good? Any questions? No? Okay. I think I'm gonna actually stop right here. I'll post the other one later. So I'm gonna stop right here. There are some questions that we're gonna actually try. So from this part here, anything in example 1, 2, 3, and 4, I have some questions for you to try. Okay. So try. So just for examples 1 to 4 for practice. And definitely a practice is really a must. So page 592 to 594, question number 4 to 8. So I'll show you what that looks like. So this is the one that's on page 492. Solve each equation. So that one, solving for x. We don't have to manipulate anything because that side is already isolated. Actually, we're going to go 4, 5, not 4 to 8, because we're not ready for 5. 4, 6. 7 and 8. Skip the 5 for now. We'll do the 5 later on. Okay. So these are the suggested questions. So give them a try, and then I'll be going around making sure everyone's is okay. Is that good?